Hello, my name is Alex Mata, and I am in 6th grade. I go to Dodson Middle School, located in Palos Verdes, and I will be presenting the ARF Clean Paw Patrol, which is my science fair project. So, we're gonna go on to the hypothesis. If my robot uses a calibrated RGB color sensor and a distance sensor to locate a dog waste metal Play-Doh and guide the 3D printed scooper and bin, then ARFBot will successfully scoop and deposit the targets into their bin in at least 12 out of 15 trials, which is around 80%, in a controlled outdoor test area. So, procedures and testing plans. So, how we set up the test was a controlled outdoor area using simulated targets on common surfaces like grass and concrete. So first, I assembled the rover and wired it using the Aligu board for the wheels and an A-spot board for the claw, for the robotic arm. And then I calibrated the color sensor using sample readings. After that, I placed the targets on surfaces like grass, concrete, and dirt if it was available. And then I started the robot from a fixed starting position and let it scan and collect. I recorded my success and fail time per pickup, and I kept repeating this until 15 total trials are done. What was measured? My collection success rate, the detection errors, aka false positives or false negatives, average time per pickup in seconds, and from my trials, I summarized 14 out of 15 successful pickups, 93.3 success, which is basically 90 seconds average pickup time. The ARFBot Clean Paw Patrol, as what I call it, was tested in a controlled outdoor area using simulated dog waste targets on common surfaces like grass and concrete. Across 15 trials, the 3D printed scooper made out of Petri and the bin mechanism successfully collected and deposited the target in 14 out of 15 trials, which is a 93.3 success rate approximately. The average time per pickup from detection to deposit in the bin was 90 seconds. But the performance got worse on the shade and lower light conditions, which is something I have to improve, and what the robot needs improvements on, which led to occasional missed detections. During extra scanning passes that aren't part of the 15 target trials, the system produced 3 false positives, where it detected a target where there was no target. And across the 15 trials, the system recorded 2 false negatives, which are missed targets, meaning it couldn't spot the waste. So that means my robot needs additional calibration, improved filtering are also needed for consistent performance and variable outdoor lighting, so it can work when it's dark, when it's light, or when it's in the middle. So the ARFBot Clean Paw Patrol demonstrated that a low-cost student-built robot can detect and collect simulated dog waste targets outdoors. The prototype achieved a 93.3% collection success rate, 14 out of 15 trials, with an average pickup time of 90 seconds, supporting the project's hypothesis of controlled conditions. But the performance decreased in shade and low light, leading to missed detections and occasional false alerts during extra scans. These results show that the design is effective and that with improved calibration, filtering, and low-light upgrades such as night vision and IR sensing can further increase reliability for real-world use.